For our 8.1 notes, we are going to be talking about exponents. So this is a word you have heard before, but we haven't really used them until now. So you've heard it in our order of operations. So we're going to start using those. So this is an example of an exponent, is this number right here, this little 3 up above the number. So what this means is that we're doing 4 3 times. 4 times 4 times 4. So it's not 4 times 3. It's 4 times 4 and then times that by 4 again. So the base is the number that is, so number used as factor. It's the number that's repeated over and over again. So it's the number that's repeated. The exponent is the number that tells us how many times to use the factor. So the number here, the 3, is the exponent, and we needed to use the base 4 times, or the factor, the base, are the same thing, 4 times. And then power is just another word we can use for exponent. So it's 4 raised to the 3rd power. So that's just another word you might hear there. So an example might be that I have 6 and I have that 3 times. So I would write that 6 times 6 times 6. So not 6 times 3, that's 18. This is 6 times 6, which is 36, times 6, which is, I don't know, 100 something. I'm not going to take the time to do it. So there's a difference between just a multiplication problem and an exponent. An exponent is repeated multiplication. So addition, when I have addition, 4 plus 4 plus 4, that turns into a multiplication problem, 4 times 3. But an exponent is repeated multiplication, 4 times 4 times 4. So we're going to write these in exponent or expanded form, and then we're going to solve them. So this means I have 5 4 times. 5 times 5 times 5 times 5. So this means I need to do 5 times 5, which is 25. I'm timesing that by 5 again, think quarters. 5, 10, 15, oh sorry, not counting by 5s, 25s. 25, 50, 75, 100, 175. So this is 175, and then I need to times that by 5 again. So 175 times 5 is 25 here, 35, 36, 37, 5, 6, 7, 8. So 5 to the 4th power is 875. So you can see, right, it got 5 times bigger, then that got 5 times bigger, then that got 5 times bigger. These numbers are going to get big really quickly. So then next we have 3 times 3 times 3 times 3. So if I write that in exponent form, my base, the number I'm using over and over again, is 3. How many times did I use the 3? Well, we used that 4 times. So if I solve this, 3 times 3 is 9. 9 times 3 is 27. And then 27 times 3, 3 times 7 is 21. 6, 7, 8. So 3 to the 4th power is 81. That's right, they get big really fast because every time I made it 3 times bigger, 3 times bigger, 3 times bigger. Hey, 2 to the 3rd, so if I write this out, 2 is my base. That's the number that's repeated, the factor. 3 times 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8. So one thing it's important to not just skip count. This is not 2, 4, 6. That's addition. That's repeated addition. We're doing repeated multiplication. 2 times 2 is 4, times 2 is 8. Hey, here we have 1/2 to the 4th. So 1/2 is the number I have, my factor, over and over again. And I have that 1, 2, 3, 4 times. So when I multiply, 1 times 1 is 1, times 1 is 1, times 1 is 1. So my numerator is 1. Now I'm taking this half and I'm cutting it in half, cutting it in half again, cutting it in half again. This one's actually getting smaller when I'm using these fractions. So 2 times 2 is 4, times 2 is 8. So this is 4 times 2 is 8. 8 times 2 is 16. So 1/2 to the 4th power is 1/16. So you can see here's our base every time. That's the number that's repeated. The smaller number, the exponent, tells us how many times we have to do that number. Hey, so which of these can be written as an exponent? So that means we're looking for a number that happens over and over, repeated multiplication. So this says 3 times 2, so they're not the same. That is not an exponent. It has to be the same number over and over again. 3 times 3, same number. 3 is the number that's repeated. It happens 2 times. 3 times 3 squared is 3 times 3. This one is repeated addition. This would be 3 times 2. So these two are the same, but they're not exponents. Exponents have to be the same number multiplied over and over again. Exponents are repeated multiplication. Repeated multiplication. So write that down so you can remember that. Okay, the last thing we're going to do for these notes is we're going to look at these examples here and decide which ones mean the same thing. So 8 times 8 times 8, that is 8 to the 3rd. 8 times 3 is 24. That's not the same thing. That's not an exponent. 8 to the 3rd power is 8 times 8 times 8. Well, that right here, we have the same thing. Oh, I'm sorry, I'm supposed to circle them. So these are the same. And this one is 3. I'm going to move my head up here. Times 3 times 3 times 3 times 3. 1, 2, 3, 4, 5, 6, 7, 8 times. Those are not the same thing. Okay, so let's look here. So 4 times 6, that's not an exponent. That's just a multiplication problem, which equals 24. 6 times 6 to the 4th power is 6 times 6 times 6 times 6. Here we have 4 to the 6th. That means I'm doing 4 6 times. 3, 4, 5, and 6. So we can see these are not the same thing. And here we have 6 is our base. That's the repeated number. 1, 2, 3, 4 times. So we can see here and here we have the same thing. Okay, I want you to go ahead and try this one on your own. So write out 5 3 times. Then simplify this. 3 is the number. How many times? Expand this one and put this one back together. Which ones are the same? See if you can go ahead and complete that to finish off your notes.